Hey everybody, this is Larry. This is day 9 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. Sorry that I think today I'm a little bit late today because I did the contest yesterday, or I did a virtual contest of the contest yesterday. And then I just kind of forgotten about it. I was very tired, still a little bit jet lagged, that's my excuse and I'm sticking to it. Anyway, hope you like today's problem. Let's take a look. 2272 substring with the largest variance. Okay. So the variance of a substring is the largest difference between the number of occurrences between any two characters present in the string. Note that any characters may or may not be the same. The two characters. Okay. Number of occurrences between. What does that even mean? Given a string S consisting of lowercase English letters only within the largest variance possible among all substring of S. Substring is a contiguous. Okay. Okay. So, So n is 10 to the 4th, so we have to be a little bit, we have to be intelligent about it versus like something more naive maybe. But, what does largest variance amount? Huh. I mean, I don't immediately have, nothing rings bell. Even though I know that a little bit of a hint maybe, and I don't know if this is true because, sometimes things are not the way they look. But we've been doing sliding windows all week, so maybe this is sliding windows. That's a little bit of a maybe of a bias, but we'll think about it. Can we do sliding window in this one? What would a sliding window look like? And then the other thing that we kind of want to maybe think about is that we are using lowercase English letters, right? And that means that there are only 26 of them, right? That means that we can use alpha or a or whatever as a parameter to our complexity, meaning that there are only 26 characters. And along those lines, I'm thinking of the first thought is that, okay, maybe we can do something like, maximize every character, right? Like maximize A, maximize B, dot, 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 right? And then the other thing that I may think about is that, well, if you're going to go that way, then why not do alpha square, right? Like 26 square or 26 choose 2 more precisely. So that lets you divide it by 2 times n, right? What 26 choose 2? Let's see. Choose 2. That's 325. 325 times 10 to the 4th. That's like 3.2 mil, right? That is on the order, but 3.2 mil. But these are these are kind of cheap operations, right? Because we're just doing like if statements and stuff like this, probably. And there are things you can do to kind of speed it up a little bit, so that you don't naively look at every character always, meaning that you can kind of, you could do some optimization. But I think that's the first thing I'm going to do, and then see if it times out. It's just using the 26 choose 2 algorithm, which means that, okay, we do it for A and then B and then C, and then, for these characters. And maybe it's 26 square, actually, to be honest. And then maybe we can think about optimizing it so that we look at each character only once, so that it'll actually be true linear. So there is a way to optimize that, so that basically in the way that I'm thinking right now is that it would be an analogous of having a sparse array, right, where you only keep track of the location of things, instead of, but we'll do this together. We'll build it together. Maybe we'll time out, but we'll do it iteratively as how I would think about the problem. And I kind of really already outlined all of them. So yeah. So okay, let's do X, and then maybe we do maybe Yeah, let me think about it for a second. Hang on. I'm trying to think whether there's a symmetry and whether I can. I know I said 26 choose 2, but maybe I'm lying on this one. Or like you have to do it in both directions in such a way that it is not. It'll be 26 square, which is an order. Not an order, but like twice as slow, which on this particular problem might come into an issue. And I'm trying to also think about how would I do the sliding window. So the sliding window in this case would be we always try to remove the min element as much as possible, right? And that's pretty much the idea, right? So basically you have a min element, right? In I don't know, what's it called? It's like a string dot lowercase ASCII or something like this, right? Or am I making that up? Just to like go from ASCII lowercase. Okay, whoops. I guess that's close enough. I haven't used this in a while. Right. Let me just double check real quick. Yeah. Okay. So yeah, that looks what I expect. And then you have like a max element also in the string dot ASCII lowercase. And obviously, if they're equal the same, then we can just continue. It's a very small optimization. Yeah, and then we also do best is equal to 0. Largest variance. Okay, yeah. And basically, now we do the sliding window, right? So left is equal to 0 for right in range of n. If s of right is equal to max element, right? So we have a sort of the current delta is equal to 0. S of right is equal to max element. We add one element, right? And then while s sub left is equal to min element, I have to be a little bit careful here, don't I? No. I do have to be a little bit more careful. Okay, so I have to do two things actually. And then else if s sub right is equal to min element delta right? And then we want to remove it from the left. So then it's something like this, but it's not quite like this because you want to have at least one element on it, right? So maybe the delta stuff is a little bit confusing. So let's just do min count and max count, and then we'll do. So then if this is the case, then max count increment by 1, min count increment by 1, while this is the case, and min count is greater than 0 because we want at least one min element in it, otherwise it just won't exist, right? So then here min count increment by 1 left delta, and then I guess that's it actually, right? Oh sorry, we this is subtract obviously, and then now if min count is greater than 0 and max count is greater than 0, though that would come up in the best anyways, then this is just the best of max. Is this true though? I think I have to be way more careful about this one too, right? Because I think this may give me no. So what I worry about is having other elements in this, right? Meaning that if you have like maybe we're going for something like VA something like this, but what if there's like C's inside? But I think in this case, and this is where we have to really be tight on the invariance, is that min element is equal to 1 exactly, right? Oh, this is, I think I did it a little bit wrong. So this is greater than 1. Alright, so that's a good catch. This could be greater than 0 because so this should be, so maybe we'll do a, well, you can't do an assertion here because technically min count could be 0 because it's before we loop into the things. But so yeah, min count is equal to 1 exactly, or it's before we encounter the min element, right? So that's kind of the invariant. And then and because min element is equal to 1, all the elements that are inside, either they don't exist or there's 0, so it doesn't even count, or they have at least one element, which is exactly what you are asking for anyway, right? So okay, so in this case, oh, then it's just max count minus min count, which is one element. Now, I don't think this is true either, right? I mean, this would be kind of true, but maybe I'm messing it up here, because you can imagine a case where you have and then here the largest variance would, you know, you cannot just remove these. So I think I'm really wrong here. Sorry, I'm kind of leading. This is a hard problem. I don't know how I did in the past, but because in this case, then you're gonna remove everything up to here, but this actually has a contribution of, you know, positive 4 or something like this, right? I was initially going to think about this way, but I think I'm really wrong here. So let me step back and think about it again. Maybe it's not sliding window, and I kind of got tricked into it a little bit. How would I think about this case? That's what I'm pausing right now on. I mean, there is some element of a stack element, like properly as we kind of explore this, but it does kind of also reminds me a little bit of Cadane's algorithm now, right? Because basically, Cadane's algorithm is the maximum sum of all these things, right? And for the maximum substring, maximum subarray sum is the Cadane's algorithm with negative numbers. And here you can kind of model this as Cadane's, where b is equal to +1, and then a's are -1. Oops. And then we're trying to get the max of that. So okay, so I think we got it now. I think, like I said, these bias sometimes don't work, and I think I was biased toward sliding window. I think I'm really wrong here. So what I only have to do is just have a kern is equal to 0, and then for I in range of n, and we'll do an optimization. The same optimization actually applies, so that's actually pretty good. For I is equal to n if s sub I is equal to max element kern +1, else, oh no, not else, you have to, it has to be else if is equal to the minimum element, kern -1, and then at the end, best is equal to max best kern, but also I screwed up the Cadane's, -1, and then if kern is less than 0, kern is equal to 0, right? Because that's where we start the new thing. This should be right, but right. Damn it, Larry. What did I do? So for B, this goes 0, 0, +1, 0, +3. I also have to do a special case here, though, right? Because otherwise it would just take these 3 as the Cadane's. But still, I don't know why this returns 0. Huh? That is surprising, actually. What's the other one? Oh, the other one I just returned 0. Did I always return 0? Is that why? Okay. I mean, I think some of the setup is right, but we have to be careful that it contains at least one A, right? Otherwise, yeah. Wow, this is a tricky problem. Oh, it doesn't even go through it. Did I mess this up? Why doesn't this go through the loop at least once? Do I have a break element? No. Why? Tell me why. I'm so confused actually. Why is it not printing? Oh, there it goes. Yeah, so... Oh, I see, because I indented like an idiot. Okay. Wow, how did that happen? Alright. Not sure why we're getting 4 now, but that's good at least. Or it's good that we're finally getting something. C and B? Oh, I see. Yeah. Because these elements don't exist, right? So that's very awkward, actually. Let me think about this for a second. I mean, I think the idea is right, but there's definitely, or like the general framework of the idea is right, but clearly we're missing some critical components because, for example, yeah, if it tries to do C and A, then, like I said, if the current substring does not have the thing, then it cannot be a max, which is very awkward. How do I modify this so that it contains a thing, right? I mean, it's the same problem as what I said earlier. We have to make sure that it contains at least the min element once before we can do this max thing. But and it's very doubly awkward because the best answer can be something like this, right? Where the min element is before the max element, so then it would just be like 0, and then, but how do you know that, you know? Is contains the right way then? I mean, the setup is kind of right, but I'm also trying to think about, was it Freud's majority algorithm, which kind of is based off the same premise, but except for that, this is only on the min element. So it's a little bit awkward. Huh. Man, you're seeing Larry really struggling today. Luckily, this is a Sunday afternoon here for me, so I have quite a bit of time and not as tired as I normally would be. Huh. How do I solve these two problems? Which are the same problems, I guess, and the same problem as example 2. Huh. I mean, we can definitely do something like found is equal to false, right? Found. and then here found is equal to true, right? But then this doesn't fix this case, right? Like I guess we can do it in 2 cases, but it still feels very awkward for me, to be honest. Right? Does this even work very quickly? It works very quickly, but it still doesn't solve. Like, okay, let me try the other one. Right? I don't think that works. Right? Yeah. In fact, it's 0. I mean, we can definitely figure out the other thing for this, but like you could do another loop where, you know, or just like add a parallel if statement, but maybe that's the way I have to do it. Fine. Basically the same idea, but how am I modifying it? I'm modifying it by saying that, okay, that means that this means that last character is the min element, right? If this is true, something like this, maybe. Is that fast enough? Now we have to worry about if it's fast enough, but I'm not 100% confident about this either, to be honest. It just seems kind of sketch. Let's see if that works. Okay, so that's the... Oh, I guess maybe I have an empty case. Okay, fine. No, I didn't know that empty string is valid, but okay, fine. Alright, I'm going to YOLO a little bit and give it a submit, but not super confident that that's all the edge cases. And also maybe that is too slow. But the too slow thing we can optimize. Okay, I mean, I thought this may be a chance because, you know, this is linear for all the things. But then now all we have to do is just convert it into a sparse array thing like we talked about, right? What did I do in the... Wow, I guess during the... Oh, I just converted to C++. Oh, Larry. Larry during the contest. But yeah, you could still... I believe you can still... I mean, that's a little bit crappy that, you know, in C++ you probably don't need an extra optimization. But in Python, I guess you do. Like I said, it's going to be about 26 square, which is like what, 5... What is 26 square? 565, is it? 676, I can do math. So yeah, 6.7 million operations or iterations or whatever. Even if it's cheap, it's a little bit expensive, I suppose. But yeah, but we can actually convert this into a sparse array, meaning that, you know, you have something like characters is equal to devoted list, and then for C, it's got positions for C and S, enumerated. Position of C dot append index, right? And then now we can just do this, but yeah. How would we do it? I mean, you could do it. There are a couple of ways you can do this on just by counters and stuff like this, but yeah, it's just annoying. That's all. Mini is equal to 0. Maxi is equal to 0. Right. So then now instead of this loop, and instead of this loop, we have something like this, and then I is equal to the this is min element maybe of min element of mini, right? If you can write this in a couple of ways, but so this is kind of yucky. Wow, I should have done this earlier because I don't know, so people could see it earlier. I didn't realize this. This is earlier position. Then you set it to here, right? And then that's pretty much it, really. And then in this case, you want to max it. Maybe something like this. Yeah. Let's delete this part for a second because I think it's the same idea anyway, and then we can copy and paste afterwards. I just want to make sure that this works. This isn't quite enough yet, but because you have to do like the trailing stuff, but you get the idea, right? You just go for the indexes one by one. Right. It's just very annoying to be precise about, I think. Yeah, maybe we just do something like and then you have to do this twice, as we said, so it's a little bit yucky. It's a little bit yucky. I need to write this into a function, maybe that'll be a little bit cleaner, but and this will only be equal to the min element. So I guess this would actually, well, this can work if it looks as false, but otherwise I guess it can terminate early. This doesn't happen anymore. I guess it could happen, but once it becomes negative, I think we can just return false anyway, or break anyway. And it, right. And then but you can no longer make it false. That will never happen again. So then you just have this, and then yeah. So this is half of it. Like we said, we didn't do the case where it's AABB, and for that reason this fails. And this one I thought should work actually. So we never change found again. Okay. So so this part we go and then we do mini. Oh, it's just that we never updated here. Huh. Alright, well I mean you should update it, right? Okay, but we knew that this one would fail because that's the part where we have to do this thing again, which is so yucky. Yeah, maybe I could have just modified this here, right? So current starting min is equal to 0, right? But then now you have to do found starting min or something. It is so annoying, but I guess it is what it is. If this is the case, close. So this is the same thing here. And I kind of didn't avoid it last time, but yeah. Oh, I cannot piggyback off this. I have to do something like this. Oh, and this is found starting then. Right. Hopefully you see what I'm trying to do. It's just I put it in parallel so we don't have to. I don't know if the other way is a little bit clearer maybe, but and now we can't even break on this because this doesn't do anything. We just because this will never be terminated anyway for the best. But what we do for this one? I guess we do this. Right? So in this case, again, it will never really. Once it goes into zero, we can never be the best answer anyway, so maybe that's fine. Yeah, once it goes before low zero, it doesn't even matter anymore. This is just to catch the case where we do negative once, convert round to true, and then do it again. Right? This is disgusting. Alright, this should be faster. We'll see if it is fast enough. It is. Maybe I could have done that during the contest. In fact, it's 95 percentile, but this is disgusting. What did I do last time? Last time I did the same thing except for I converted to C++ because I was too lazy to. Well, I don't know if I knew how to do it. I also make sure that it's seen. Maybe I could have done that. Let's actually add that optimization real quick. I don't think that matters though, but because this would, yeah, I think for this code it doesn't matter. For that code, maybe it does a little bit. It doesn't matter because one of these will be zeros, and then you just go through the linear way. So I don't think it matters that much for this particular solution. Yeah. Whew. So this one actually, even though it looks like alpha is part of the input, alpha being the size of the alphabet, it actually turns out that it cancels out because each character only gets seen once or twice or 4 times or something like this, a constant number of times, basically once on the min element, once on the max element, and maybe you could say twice depending on the, on these loops or whatever, however you want to say it. So this actually turns out to be linear time and linear space for that reason. So yeah, this is a very, very hard problem. Let me know what you think. And yeah, hopefully this. Let me pause a little bit and show you the code. Here's the top. Here's maybe the bottom. If you want to see, this is disgusting. I don't even know where this function begins. All right, let's just do the while loop here, and then also here. If you want to pause and take a look. Yeah. I'll probably do a drone video tomorrow if we get an easier problem, but yeah, that's all I have for today. That's all I have for now. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.